I'm in the Hydrology and Statistics division. Matt used to be my boss before he moved to water management. Now I report to Greg Karlovitz. Mostly do development in HMS. Yeah, before I came over to HEC, I was with Fort Worth District. I did some cool elliptical design storm studies with Simeon, who I see is on the call, but never really got a chance to do a lot of things related to water management. And so I'm looking forward to showing off to you all what I've done so far with forecast optimization. But then I'm also equally looking forward to getting your feedback, because I know as water managers, you might, I know you think about things differently than I do. And so your feedback's very valuable. This will be fairly short. So if you have any questions at all, don't hesitate to come off mute and ask your question. I've prepared a link. I was going to try to post it in the chat, but it says that it's having trouble refreshing my messages. So anyhow, I'll get the link to you all somehow, but it has a tutorial and guide that I've created. And it also has the model that I'll be demoing today, as well as a special build of HMS. So if you're so inclined, you can go ahead and download that and start testing out some of the optimization enhancements. All right. I'm going to stay outside of presentation mode because I'm going to be bouncing between the slides and HMS and then a web browser. So kind of a quick outline here. I'm going to start off by going over the optimization trial enhancements. If you're not aware, similar to the forecast alternative, this is a compute type that's in HEC-HMS. And for forecast optimization to work, this is where I'd say probably 95% of the effort has been concentrated. We had to basically gut the way that the optimization trial has worked in previous versions and rebuild it for version 4.14 in order to do the things that we want it to do. So I'll give a demo of that. Again, that's in a very good place right now. It's ready to test. And then I'll kind of go over some changes specific to the forecast alternative. Mostly it's UI related, user interface. So I'll show you what's already been done, and then there's just a little bit left to do with that. But I'm hopeful to have everything completed in time for version 4.14, which should be released, if I had to guess, later this calendar year. All right. Any questions so far before I jump into some of the optimization trial enhancements? All right. So in this slide here, I think it helps to look at the way it's looked in version 4.13 and prior, and then kind of compare it to the changes I've made for version 4.14. So the two biggest things, if I had to sum it all up, would be that now, starting in version 4.14, it's allowed for you to be able to identify or to parameterize multiple objective functions instead of just one. So really what this means, as you look in the bottom image here, is that I can specify multiple locations throughout my watershed. So that's a huge change. It also allows you to specify the same location but different time windows. So for example, if you were doing a continuous simulation over, let's say, a month, and you had 2 or 3 independent events with 2 or 3 peak flows, and you were just interested in finding an optimized parameter set that matched the observed peak flows, you could specify the same location, but then different time windows corresponding to each of the peak responses, and that would give you a parameter set optimized just considering that observed data that takes place near the peaks. So that's both of those are now opened up by being able to specify multiple objective functions, and then now multiple searches are allowed. So you'll notice here there's a new combo box window here, objective search type. There's two options. There's sequential searches, which is the new feature, and then there's single search, which is the way it's worked in the past. So essentially, how this functions, the sequential search is that if Hauserville, I'll go ahead and pull over a basin map here to kind of provide context. So if you were doing a sequential search and you wanted to optimize for the Hauserville location and Axman, the way that that would work is that it would run two searches, one right after the other. So the first one, it would run and it would consider the parameters associated with the subbasin above Hauserville. And then once that optimization trial converges on that optimized parameter set, it would lock those parameters, move to the next downstream location, and then optimize for Axman in this case, while keeping the previously optimized parameters locked. And it would do that marching all the way down the basin model to your outlet. So this is one of the features that needed to be implemented in order for forecast optimization to take place. All right. Another feature that needed to be implemented for forecast optimization is this concept of an optimization parameter type that I'm named subbasin zone. So this is a new option with version 4.14, and it behaves similarly to the existing all subbasins option. So if this was selected, it would optimize parameter sets based on all subbasins in the model. Subbasin zone is similar, except it optimizes for just the elements within your zone. So this is a new feature for version 4.14, and this is what the forecast optimization is going to leverage, and it's essentially going to take these optimized scale factors, and then at the end of the compute, plug it into the override tables associated with the forecast alternative. And if you're not sure what I'm talking about, I have some slides later on that'll kind of go through that workflow and outline it a little bit better. All right, any questions before I jump into a quick demo?
Yeah, Josh, if you wouldn't mind, go back to slide 3.
Okay.
All right, so here, just painting the picture one more time, like currently in HMS, is only one location that you can optimize to. So if you have your large model, then its optimization really doesn't work for large models with hundreds of locations, because you'd have to create trials, lots and lots of trials, and you would run out of time. But with this, what I love about this is that bottom figure for location. I'm guessing in that table, you just click on the one cell in the location column and you can choose, is it computation points or is it any location that has observed flow?
I believe it's locked down to observe flow.
Okay.
Because that's going to be needed.
Perfect.
For the
now.
routine.
So instead of having 100 optimization trials, you would just have 100 rows that start from the headwater location with observation, with observed flow, and then ended at the outlet of your entire basin model.
Right.
Okay, so that's really exciting. And the sequential searches, that's the piece of the new brain, I guess, that knows to march from headwaters to the outlet. And is it using hydrologic order?
Yes. So I guess maybe diving a little bit into the weeds here. But right now the sequential search is locked down to using optimization parameters that are based on elements. And so for that, it does use hydrologic order. It'll start at the most upstream element and then march downstream. For zones, though, and this is again where my my lack of water management experience kind of catches up with me. I think with zones, you can set those up any way you like. Correct? You could choose a couple of headwater subbasins, and then you could choose a subbasin closer to the outlet, and that could technically be in one zone, but not make much sense, correct, in terms of hydrologic order?
That's correct. Yep.
So I think for the way that water managers would need to use this is hopefully the zones are kind of already set up to where they make sense in terms of hydrologic order, but I'm not really sure how to enforce that. I'd be open to suggestions, but right now it's kind of on the user to make sure that the zones make sense in terms of hydrologic order and where your observed data is located throughout your basin model.
Okay. Is it so if the zone option was selected, would it just march the way that we add them to the table or whatever list there is of zones? We would just need to make sure that those zones are in some hydrologic order that makes sense so that the optimization is looking at observed flow upstream to downstream.
Yes, that's exactly right. Yep. And I've got that piece is done. I've got a screenshot of that table later in the presentation.
All right. Any other questions so far for Josh?
For your optimization trial, are you able to do multiple parameters?
Yes. So yeah, I'll show you some.
Yeah. Go ahead. Sorry.
Yes. You're not limited to the amount of parameters. So for each zone, you could choose a couple of scale factors, or you could choose all available scale factors. I do need to. I'll get into this a little later on, but for whatever reason, the scale factor framework hasn't been set up for base flow in HMS. So I'm in the process of getting that added. But your transform parameters, your loss parameters, most of your other, method types, those are open to you to choose. And I'm working on a feature now that should help you, because if you've used the optimization trial before, kind of the knock on it is that it does take time to set up your optimization parameters. You have to kind of do them one by one. And you can imagine if you have a large basin model with lots of elements that you want to optimize for and several different parameters for each element, you could end up with hundreds of parameters. But I've taken that into consideration with a table that I'll show you later in the presentation, and it helps you quickly create the parameters with some defaults that I think should work well for most basin model setups.
Interesting. Yeah, because I was just so like when you're setting up these optimization trials, you said it's at observed flow locations specifically. So let's say that you're already doing like something similar to like you're doing the forecast initial base flow where you're actually setting the upstream boundaries to that gauge flow value. How do those I don't know how to word it, how do those interact when it comes to the using both those kind of things together?
Are you talking about how you march down to your different control points with the observed data? I'm sorry, I'm not quite tracking the question.
Yeah, sorry. I'm probably not even wording it properly. It's a weird concept, but so at a lot of the locations where I have observed flows, so I'll set the initial actual flow value to those within the forecast initial base flow. Like you can set it to gauge flow to start with. So that's what I was trying to, and then I was just wondering how that would overlap with the optimization, which is kind of also using the observed flow to do different calculations, I guess. I don't know.
Yeah, gotcha. Yeah, I haven't, I'm not sure how that would work currently, but that is something that I'm going to, that's exactly the kind of feedback that I need. So I'm going to make a quick note of that.
So my guess, I'll just throw it out there. There's a layer cake of importance here. So you have your base parameters in the basin model. That's at the bottom of the stack. The next thing that overwrites those is going to be what's in the zonal editors, right? So your zonal overrides. So if you have a zonal override for initial base flow, then that will win. What sits on top of that one, though, is that initial base flow specific editor, right? So if you're linking the initial base flow to a gauge, then that overwrites what's in the zone editor, which overwrites what's in the basin model. So my guess is that even though optimization might attempt to find the right initial flow, the information that's being pulled from the gauge that's linked to it in the initial subbasin base flow is going to overwrite that.
Gotcha.
Yes.
So it's like that makes sense.
Yep.
Yeah.
And then it looked like David Varner asked if it can be used for snowmelt parameters.
Haha, good question. Yeah, thanks. Sorry, I don't know why I've never had this issue before, but I cannot see the chat. But yeah, so for snow melts, I was actually talking with Mike Bartles about this yesterday. I have a slide of a few things that I'm still working on, and that's the piece that I'm working for. Those would, I believe, need to be optimized first. Any parameters related to snow. But yeah, you have any thoughts on that, Matt?
Well, yeah, it's kind of related to Paul's question too, is can we mix and match the variable that we're optimizing to, right? Because flow is what we initially think about, but with SWE and reservoir stage, can we create a trial that has observed information for all three of those variables within it? And I'm not sure. I don't think the optimization trial lets you choose stage and SWE. Well, yeah, it does let you choose SWE. I know it does. I'm not sure about stage though. I'd have to dig in.
Yeah, that's on my kind of investigation list. Being from Texas and most of my application experiences within Texas basins, we call that stuff devil's dandruff down here. We don't get it often, so I'm pretty ignorant when it comes to snow. But that is something that it's on my radar, and yeah, I'll be checking in with Mike and Matt and you all, people that are more familiar with it, to make sure that gets implemented in a way that makes sense. All right.
All right. Well, yeah, we'll let you keep going.
All right, so I'm gonna just do a quick demo here. This is going to be showing off the way that the sequential search works. So this is the West Branch of the Susquehanna River, and I've selected an optimization trial. So in this trial, I have I'm just going to go ahead and compute this because it does take just about a minute or so. Move that over. Okay, so I've got 10 parameters in total. The first 5 are related to the first optimization that's taken place for Hauserville. So that's what's going on here. You'll notice that the progress bar says searcher 1 of 2. Essentially what it's doing is it's honing in on this, in this case, just one subbasin element. So the 5 parameters associated with Spring Creek above Hauser, it's getting those optimized for. And then after, I believe, about 130 iterations, it'll converge. It'll lock those parameters into place, and then it'll march downstream to the next objective location, which is Axman. So these subbasin parameters for Spring Creek, they'll be locked in, and then the second search is going to be honing in on Spring Creek above Axman subbasin. And so you can imagine with, a larger basin model, you might have specified dozens of these control points. And so if you specified a dozen control points, then there'd be 12 searchers that would be computed one after each other. So the idea is, as a water manager, from what I understand, you spend quite a bit of time in the morning getting your model calibrated. And so being able to automate this to run in the morning, maybe before you get into work. And then once you get into work, you'll have a decent calibrated parameter set to work with and kind of get you jump started. So this is,
while that's running there, lots of iterations is great. But if we have big models with, let's just say 20 calibration points, is there a way to control? I guess we can set the max iterations per point to be 20, because we think that's good enough. Is that possible?
Yes, absolutely. So yeah, on the search tab here, this is the same that it is in current versions. You can control the max iterations and the tolerance. I've done some testing with the zonal scale factors for the subbasins, and they don't need nearly as many iterations as individual parameters for individual elements need.
Okay.
Based on what I've found so far, on the order of 20 to 30 iterations usually is good enough for it to converge and reach a different or a decent answer.
Okay, perfect.
So should be helpful when it comes to basin models that are much bigger than this one. All right, so that's converged. I'll just go over to the results and we can kind of see how that's oriented now. So let me expand it. So you have two folders, one for each, in this case, objective function, but one optimized parameter set. And so we have the optimized parameter set here. And then I'll show you how it compares to the observed data for both. So we have Hauserville. You can see we have good agreement with the upstream most location. And then we also have good agreement with Axman further downstream. All right, I did want to show you one other neat thing, not really related to forecast optimization, but just one of the cool enhancements that kind of came along with this. So I mentioned the multi-window thing. So this is how that would look like. You could specify the same location, but for each location, you could specify a different start time and end time. And that's the observed data that would really be honing in on each individual window. And so I've already ran that just to kind of show you what that looks like. And this is kind of maybe a little bit of a silly example because this is a single event. But if you looked at the observed data, make this a little bigger. This is for the first window. And then we have this for the second window. Let me see if I can get these up on the same view. That one, this one. All right. So you can see it's the same computed results because each objective function has the same location, but it's really zeroing in, on this case, on the peak and on the recession limb. You'll notice that on the rising limb, it doesn't do as well. That's because that wasn't the goal of the objective search in this case, because we specified the different time windows. So that's kind of cool. I haven't really played around with that much, but I think when it comes to continuous simulation, that might be a feature that gets used pretty heavily. All right. So I'll find a way to get you the link. I'll just show you that real quick. So I've created this tutorial and guide. This is open to the public. The same model that I just had open and I've been playing around with, that's been made available. And then I have a link. This is an unofficial version of HMS, so I wouldn't use it for anything else other than kind of exploring this tutorial and guide and maybe doing some testing. This includes all of the optimization trial enhancements to date. So I encourage you to test it out because I haven't tested it on many projects other than the one that I just showed you. And so I'd be all ears if you find anything wrong or if you have any suggestions on how things can be improved. Definitely feel free to reach out to me. So now we just have a couple of minutes left. So I wanted to show some graphics of the things that have happened for the forecast alternative. And again, this kind of looks and feels a lot like it did before. So on your main component editor for the forecast alternative, you have one additional combo box. It's labeled zonal optimization, simple yes, no. It'll always default to no. So if you open an old project in version 4.14, it'll show up as no. But once you toggle this to yes, it automatically creates another tab that it'll appear right up here. And so this is what that tab looks like. And this is what Matt kind of alluded to earlier. where you specify your zone and a control point for each zone. And then in the third column here, you click it and then it opens up all of the available scale factor options that you have for that specific zone and control point. So you can choose one or you can choose all of them if you want. And the thing that I think is cool about this that's going to save a lot of time is that once you save this table, it automatically creates your optimization trial. And based off of information from the forecast alternative, such as the look back period, that's what it uses to automatically create your optimization trial and get it all the way parameterized to where ideally you could probably compute it just right off the bat without having to go in and make individual tweaks. The fact that you're dealing with scale factors, I think, makes it a little bit easier to establish your defaults for each of your parameters. I think, maybe dividing your initial value by 4, maybe that's a good minimum, and multiplying it by 4 is the maximum to at least get you started for most of the scale factors. Yeah, so that all your parameters will be created and your everything to do with your optimization trial. So this is kind of the workflow that I'm anticipating. So you toggle on your forecast alternative to yes. It brings up the table that we just looked at. Once you get this filled out, you hit save. It creates your optimization trial based off of the look back period from the forecast alternative. It fills that out for you. And then it automatically adds all of the parameters that you've selected, and it fills those out based on defaults. You hit compute, and again, this is not, just imagine no snow at the moment, but you hit compute, the optimization trial does its thing, goes through the sequential search. Once that's finished, it takes the optimized scale factor values for each of the zones, and then it plugs those into your zonal override tables. And so that's kind of what you see here. It's going to use the scale factor, the asterisk multiplication to do that. And then automatically after that, the forecast alternative computes as it normally would, considering these overrides, and gets you hopefully a pretty good starting point with a forecast. So that's it in a nutshell. Just really quickly, because I'm a couple minutes over time here, what's left to do? That zonal optimization table that I showed you, I've got to work out the logic in that a little bit. I mentioned implementing scale factors for base flow parameters, and then I need to sit down and maybe finally really understand how snow works in HMS. And so those are the things that I'm thinking about. And again, really open to all of y'all's feedback. Now that it's in kind of the development phase still, I have it's low cost and low energy to make changes now as opposed to later on. So look forward to hearing your feedback, positive and negative. I'm seeing a question from Leah.
Yeah, for the, obviously if there must be some kind of range for each parameter that it's able to go in. Are you able to be like, well, I know in my basin it's unrealistic if it's over 100 or whatever. Is that something that we can control, or is it just a default that is set?
Yes. So I think the way that I have it kind of planned out now is that, once you fill out this table and all you're doing is selecting the parameter here, the scale factor, it'll create each of your parameters with defaults, but then you can always go into these individually after the fact and change these maximums and these minimums to things that make sense for your specific need. So that's definitely open to you.
Okay. And there are defaults in there, so we don't necessarily have to come up with something.
Well, yeah, this is a big red X. Don't use the defaults that HMS provides you because they're gigantic. So go to each of these, and for like the minimum and the maximum for your time of concentration, you probably know that it doesn't go smaller by more than 20% and larger by more than 20%, right? So the minimum scale factor could be 0.8 and the maximum scale factor could be 1.2, right? So you should definitely tweak those or modify those min and max values based on what you know, because HMS has the biggest possible range in there by default.
Yeah, so if you were to, just to kind of expand on that a little bit, and if you were to just do create an optimization trial, so this has nothing to do with forecast optimization, you create a parameter, as Matt said, it has really large ranges, but if you go through this workflow for forecast optimization and you select your parameter, I'm going to override the HMS defaults and put in my own defaults. So I will have these created and tighter ranges. But with that being said, you can still go in and override Josh's defaults if you'd like to. And if you have any suggestions on good defaults, I'm going to do testing on a bunch of different watersheds and try to come up with max and mins that work for most cases.
Cool. Well, thanks for doing that, Josh. That's going to be a time saver there. Paul Simon had a question. Paul, the list of parameters yet, are you asking about like the summary table of final values, or?
Oh, I was just like, I know there's not every parameter is on the table to optimize to, and you may have already kind of covered it. I just didn't catch it.
And this table here that I have is
which
Yeah.
parameters can we optimize to? Yeah.
Gosh, I should have had a table, but I think pretty much all the ones that you need.
Okay.
With the exception being, I have to implement any base flow. So I talked with Matt about this earlier, and we identified recession base flow and linear reservoir base flow. So we're going to open up some parameters related to those two specific methods, but all your deficit and constant, your initial constant, your Clark transform, pretty much all your standard scale factors you'll be able to choose from. This table's still under operation, so I just like hand jammed 3 parameters in there for.
Right. Sure.
Yeah.
So it'll work whether it's Clark or mod Clark, correct?
Yes.
And then can you only optimize to flow, or can you optimize to stage or elevation? Like a reservoir?
That's something for me to investigate. Right now I've only tested with flow.
Okay.
Yeah.
Because sometimes like I always like to calibrate to pool in the reservoir, because depending on how well you screen your pool elevation data, even if you calculate and try to smooth your hourly inflows, they can be pretty choppy. I'd hate to, and anyway, it'd be a lot better if you could just try to hit your pool elevation.
Okay. Awesome. Thanks for bringing that up. I'll make a note to look into stage.
I'll figure out how to get you that Twix bar.
Make sure make sure it meets your needs first. I want to earn it.
All right, Josh, I know you said this at the very beginning, but this is a good way to wrap it up. And we have a beta copy to start testing, but for the optimization of forecast alternatives for 4.14 beta 1, or when do you think that would be available for us to start taking a look at?
For these, basically this whole thing that you're seeing on the screen now. Yep. My goal is to have that testable by June.
Okay.
And so I think if I can stay onto that goal, then that will make it into 4.14 as well. I probably shouldn't have said that. Hopefully nobody's recording, but that's the goal.
We are, but we won't hold you to it. We understand life happens, but this is a great goal to shoot for. Well, thank you for showing this to us, Josh, today. It's perfect timing for what we're talking about this week, and it's something for us to really look forward to.
Good deal. Thanks for having me. I'm bummed that we couldn't all be in Fort Worth right now doing this in person, but this was fun. Thanks for having me.
We thank you very much for your attention through this presentation. If you have any additional questions, would like help, or are seeking additional training, please feel free to check out the links on the screen that are also linked below in the description. If you'd like to stay up to date in whenever more of these videos become available, please go ahead and like and subscribe, and you'll get notifications anytime more presentations or video walkthroughs are posted to this water management channel. Thank you so much and have a wonderful day.